Hi everyone. Today the topic is vector and the fourth video. This is already previous videos already we discussed the adding of two vectors and the angle between the two vectors. The next video is resolution of the vector. Resolution of the vector. What is the resolution of the vector? Why we are using this resolution of vector? Every topic we should just use the resolution of the vector if the particle is moving other than the x-axis and y-axis. For example, we want to find the two dimensions first. Resolution of the vector, two dimensions. First, we want to write the two dimension means it requires the x coordinate system and y coordinate system. Okay, x coordinate system and y coordinate system because of two dimension. It requires the two coordinate system. If the particle is moving other than the x-axis and y-axis, for example, it's making an angle theta. It's making an angle theta. For example, these resultant vector is a bar vector. Okay. If you want to find the how the finding the displacement of these particle, everything will be we need to find the resolute the two components. Two rectangular components are there. How can you calculate? For example, we want to draw these dotted lines, and here only we want to draw the dotted lines. This is the y-axis. Always this is also y-axis because of those are in parallel. This is x-axis. This is also x-axis. If you want to find the these component and y component and x component, we need to find first. Okay, how can you find out the component? We can use the trigonometric functions. Okay, for example, from this equation, we want to find the component. First, cos component, we want to find the cos theta. Cos theta means adjacent side by adjacent side by. Okay, we can write shortcut. Adjacent side by hypotenuse. Adjacent side by hypotenuse. Adjacent side means what? The triangle will be angle with edge. That is called the adjacent side. What is the adjacent side? For example, this is the AX and this is the AY resultant component. That's a cos theta is equal to what is the adjacent component? This is called as a X. Yes. And what is the hypotenuse here? A. For example, this is the AX. Okay, this is the AY. Adjacent side by hypotenuse. This is the hypotenuse. We know the very well. The triangle will be there. The theta, which is opposite, this is called as opposite side. The theta where the edges is placed, that is called as the adjacent side. And perpendicular to oppositely placed, that is called as the hypotenuse. Okay, from these equations, we want to find here. From AX means what need to write? A cos theta. AX means A cos theta means which is got the here horizontal component. Whatever the circuits, whatever the concepts is there, we can apply the adjacent side will be getting the which component? Cos component. Next one, we want to find the sine component. Sine theta means what? Opposite side by opposite side by hypotenuse. Opposite side means theta is oppositely is there, that is called as a y. That's a called as a AY. Here only also parallel AY. That's why we need to take the sine theta is equal to AY by hypotenuse A. That's why we want to find the AY is equal to A sine theta. It's a cross multiplication. Means AY is equal to what we got here? AY is equal to A sine theta. Okay, this is the horizontal component. This is the vertical component. Whatever the displacement or force, whatever the physical quantities are there, we need to consider based on the adjacent. We got the cos component and the opposite side got the sine component. Okay, from these, ax is equal to a cos theta, ay is equal to a sin theta. What is the resultant vector? Resultant vector means what here? A is equal to, we know the Pythagoras theorem. Hypotenuse square is equal to side square plus side square. We can apply the according to the Pythagoras theorem. According to the Pythagoras theorem. Pythagoras theorem. Okay, what is the Pythagoras theorem? Has explained hypotenuse square. Hypotenuse means a square. A square is equal to side square plus side square. Means ax square plus ay square. Ax square plus ay square. Then a is equal to what we got here? Square root of ax square plus ay square. Square it will becomes square root of ax square plus ay square. This is the we want to find the resultant vector. What is the angle can be changes, the direction can be explained by the theta. Okay, we want to know about the opposite side and adjacent side. Which component we can apply? Tan component. Tan theta is equal to what? Opposite side by adjacent side. Opposite side by adjacent side. Opposite side means what? Ay. Adjacent side means ax. That's a tan theta. We got the direction also. Then theta is equal to what need to write? Tan inverse of ay by ax. Ay by ax. Already two dimensions is discussing now. Yes, so what is the horizontal component? A cos theta, vertical component A sin theta. Based on the we want to apply the trigonometric functions. Okay, if the body is moving other than x-axis and y-axis, we want to resolve the two components. The first component, rectangular components are there. First one is the cos component, second one is the sin component. Whatever the given the physical quantity, just we can apply here. Okay. But in other cases, sometimes asking the in a different way, resolution of the vector in different circuits, we'll discuss. Examples we want to take here. How can you find out? Example. For example, we want to take here. But if it is a horizontal component, that's a we can find out easy. For example, if you want to take the vertical component, for example, x-axis, this is the y-axis. If the particle is moving, it's making an angle with vertical component, that is the theta. Vertical component, that is the theta. What need to write here? Here only ay, here only ax. What happened if the triangle is there? Yes, say ax means here only ax. Opposite side means ax. This is the parallel. This is called as a ay. Yes, from this angle and from these components, we need to write the horizontal component and vertical component. Ax means what we got here from this theta. We want to write the sine theta. What is the sine theta? Opposite side by hypotenuse. For example, a bar is a hypotenuse. That is the a. Then ax is equal to what need to write? A sine theta. Here only getting the a sine theta. In the previous diagram, the angle making with the x-axis, but here only angle making with the y-axis. That's why component can be changes. But the theta adjacent component will be there. That is what we got here. A cos theta. Simply we can say. And the opposite side is called as a sine component. Wherever you can take the theta, then based on the theta, we can use the two components. That is the rectangular components. One is the horizontal component, and another one is the vertical component. Okay, from this circuit, ay is equal to a sin theta, ax is equal to a sin theta, ay is equal to a cos theta. In this circuit, in the previous one is different, this one different. Only the angle can be changed, the component. If the theta is adjacent component is there, cos component will be getting. If the theta opposite is called as a sine component is getting. Are you able to understand? Okay, some few examples we'll discuss. If the another example we want to take here. If we want to take the an inclined plane, inclined means some making an angle theta of this one, and one side is the some height will be there. That's called as inclined plane. Okay. If the block is placed, if the block is placed, then what happens? The block having normal reaction which is act as a perpendicular to the surface. This is the perpendicular to the surface. That's a normal line axis. But weight of the body acts as a vertically downward direction. Weight of the body acts as a vertically downward, that is called as a mg. Weight of the body means mg. From this, what is the actual position? This is the actual position. What happened when the changes some angle? How much angle is there? How much angle of inclination is there? Same angle will be there. Okay, that is the theta. Same component will be getting. It's look like a right angle triangle. Yes, right angle triangle means same theta adjacent component. What we got? It's a resultant vector mg cos theta, and another component is the mg sine component. Mg sine component. This circuit will be there. It's a like this. Okay, it's a theta. This is the mg. Okay, this is the mg. What happened? This is the triangle. Yes or no? This triangle will be acts as a C. Actually, this is the path of O will be there. This is the we need to write here. This is the right angle. This is the hypotenuse. This is called as a mg cos theta. This is the resolution of the vector. This is called as a mg sin theta. In that cases, we can now resolute the vectors. When the body is placed an inclination of the object. That's based on we know to know about the how to resolute this one, horizontal component and vertical component. Sometimes another example, if you taken as a simple pendulum, if you want to taken as a simple pendulum, for example, some one bob is there suspended freely. If you drag the bob, what happens? Tensional force will be takes place because of when the string is connected by the bob, always tensional force is acting on the string. Okay, actual weight of the body acts as a downward direction. That's a called as a mg. But normal reaction acts as a in this way. But how much can be changes? Here only how much angle is there? The corresponding angle here also same theta. What happened? This is the resolution of the vector. This is the resolution of the vector. It's a theta. Theta means what happened? Here only t cos theta. Here only t sin theta. Are you able to understand? Some of the concepts will be based on the vectors. That's called as a resolution of the vector. Simply we can remember it. If it is the theta where it is placed, the side is a adjacent side, always getting the cos component. And the other side is called as a sine component. That's a easy. Okay. How it is getting already I told you na in this video. Okay, next one. It's if you want to find the in three-dimensional way, resolution of the vector in three dimensions way. Resolution of the vector in 3D in terms of three dimensions. Okay, three dimensions means it requires the three coordinate system. First of all, we want to draw the three-dimensional way. See, always will be takes as a one cube. Will be takes in a three dimensions way. We can draw this. Okay, this is the x-axis and this is the y-axis and this is the z-axis. If the particle will be moving like this, if the particle moving in this way, okay. From this, for example, this is the A bar is a resultant vector. This is the x-axis, this is the y-axis, this is the z-axis. Three dimensions we can say the resolution of the vector. For example, on the x-axis it's making an angle some alpha. Okay, some angle, a resultant vector with y-axis is called as a beta. Yes, and another one is there that is called as a on z-axis, that is called as a gamma. Okay, always based on the horizontal components we know. Yes, means adjacent components. We know the adjacent component, here only adjacent component, here only adjacent component. Means z-axis means it's look like outside, but it can be shown on the board like this. Okay, from the z-axis also is the adjacent side, means we want to find the cosines. We want to find the cosine. From these, we want to find the resolution of the vector. What is the resolution of the vector? For example, A bar is there. The resultant of the vector, how can you write? Based on the already we discussed according to Pythagoras, two dimensions we can say a is equal to ax square plus ay square. Already we have done in the previous one. Yes, because of two coordinate system, that is the two dimensions. Now we are discussing the three dimensions. Three dimensions means what need to write? Square root of ax square plus ay square plus az square, because of through three coordinate system. Yes or no? From these, we want to find the cosine values. Why we are finding the cosine values? Because if you know the adjacent component, here only adjacent component for beta, gamma for the adjacent component. Adjacent component means which the trigonometric functions we can apply cos component. That's why cos waves we can find out. Okay, this is the magnitude. We want to find the direction also. This is the magnitude of the three dimensions way. What is the directions is there? Along the x-axis, already unit vector we discussed in the previous videos. Always x-axis means what need to represent the unit vector? I cap, y, j cap, and k and z indicates the k cap is the unit vector. Unit vector means whose magnitude is 1. It can be shows the direction. Okay. From this direction also we know. From the direction also we know. How can we say? A is equal to ax I cap. Ax I cap means along the ax, which unit vector is there? I cap on x axis. Ay. Along the y axis, which cap is there? J cap. And az. Always which cap is there? K cap. That's a direction also we want to find easy. Yes. From these, we want to find the unit vector and resultant vector is there. How can you say the resultant vector? For example, A is equal to, it's a unit vector. What need to write here? It's a unit vector of resultant. What is the value we want to write here? A bar by modulus of A bar or A. Yes. What is the A bar here? Ax I cap plus Ay j cap plus Az k cap by modulus of A means A. Modulus of A means magnitude. Magnitude means A. It's writing the ax square plus ay square plus az square. This is the actual unit vector we want to find the in these three dimensions. But actually cosine angles also we want to find it. Okay, we were first of all I need to rub this one side. We can do this manner. See, the first one cos alpha. What is the cos alpha? Cos alpha means what? This is the cos alpha. This is the triangle. Yes, this is the triangle. Cos alpha means which component is there along the x-axis? That is the ax. This is the ay. This is the az, z-axis. We want to cos alpha means adjacent side by hypotenuse. Adjacent side by hypotenuse means ax by a. Ax by a. That's why ax means what need to write here? Ax, it's a component, that is a cos alpha. Next one, cos beta. What is the cos beta? Ay by a. Next, cos gamma. Cos gamma means az by a. Already az. Yes. Along the which component, which angle is there? Gamma. That's az by a. If we want to find the one important question for IIT and NEET level examinations, asking, that's a very important, cos square alpha plus cos square beta plus cos square gamma is equal to 1. This is the proof is there. I will explain. Okay, cos square alpha plus cos square beta plus cos square gamma is equal to how much is there? 1. That's a very important question for IIT and NEET level examinations. Okay, we can apply here. Can I rub this diagram? Okay, after rub this diagram, we can use these values. Okay, what is the first one here? We want to prove. See, cos square alpha plus cos square beta plus cos square gamma is equal to 1. What is the cos square alpha? Ax by a whole square plus cos beta ay square ay by a whole square cos gamma az by a whole square is equal to, okay, we want to find is equal to 1 or any other number, we can prove it. Okay, what is the first one? A square, a square, a square, always the LCM is a square, ax square plus ay square plus az square. Okay, next one. Okay, what is the value? A square means what? From this diagram, we can remove the root. We can write the a square. A square means what need to write? Ax square plus ay square plus az square. In place of a square, in place of a square, we can write the this value ax square plus ay square plus az square, and the get cancel is equal to 1. Is it satisfy this value? Yes. Cos square alpha plus cos square beta plus cos square gamma is equal to 1. Okay. From these, in that cases, one of the important question also asking for IIT and NEET level examination. See, that question also we'll discuss. Okay, you can remember this value. Cos square alpha plus cos square beta plus cos square gamma is equal to 1. Sometimes asking the one of the important question. Okay, see, this value you can remember. Okay, I will drop this one, everything. This value you can remember. Sometimes asking the sine square alpha plus sine square beta plus sine square gamma is equal to how much? Asking the question. Okay, from this value we can apply here. But how can we apply? See, sine square alpha here only there, but we got the only in terms of cos. We know the trigonometric functions. What is the trigonometric functions? Sine square theta plus cos square theta is equal to 1. Yes, we know very well. Then sine square theta, how can you write sine square theta in terms of cos square theta? 1 minus cos square theta. 1 minus cos square theta. In place of sine square theta, we can apply the 1 minus cos square theta. See, sine square alpha 1 minus cos square alpha plus sine square beta 1 minus 1 minus cos square beta plus 1 minus, what is the value? Cos square gamma is equal to, okay, from this we can't find it. Yes, 1 plus 1 plus 1 3. Yes, 1 plus 1 plus, okay, minus cos square alpha minus cos square beta minus cos square gamma. Okay, from these 3 minus, take the common. How can you write? Cos square alpha minus, so plus cos square beta plus cos square gamma. Why we have got the positive value? Minus common. Minus into plus minus. Minus into plus minus. That's why we got here. From these 3 minus cos square alpha plus cos square beta plus cos square gamma is equal to how much is there? Is equal to 1. That's why we want to write the 1. 3 minus 1 is equal to 2. That's why we can write the sine square alpha plus sine square beta plus sine square gamma is equal to 2. That's a very, very important question for the IIT and NEET level examinations. Okay. Next one. Next one, how to add the two vectors. How to add the two vectors in a 3 dimensions way. Okay. How can we add? See. First of all, we need want to find the, for example, a vector. A vector means ax I cap, ay j cap plus az k cap. Another vector bx I cap means on x axis, j cap means y axis, k cap means z axis. By j cap plus bz k cap. Okay. By doing this adding these two vectors, a bar plus b bar. Okay, we can add here. What is the x-axis there? Ax plus bx. Common the on x-axis I cap. Okay, by doing this one. Okay, next one, this one. Next one, this one. We can write here. On y-axis, ay plus by j cap plus az plus bz k cap. That's why we can add simply. Okay, by adding the two vectors in a three dimensions way. Okay, whatever the sums asking you, we can add simply. Okay, I cap means unit vector. That's value is 1, whose magnitude is 1. The unit vector. That's why we can add directly. We'll got. Okay, we got the answer. This is the three dimensions way. Yes. See, this is the three dimensions. So for example, one example sum we want to take it out. Same three dimensions. Ax, for example, a bar is equal to, okay, 2 I cap plus 3j cap plus 5k cap is there. Okay. Next one, b bar is given 4 I cap minus 2j cap minus 2k cap is there. How can we add this one? A bar plus b bar. Okay, I cap is there 2 plus 4 I cap plus 3 minus 2 j cap. Next one plus 5 minus 2 k cap. Okay, 2 plus 4 6 I cap, 3 minus 2 only 1 into j cap plus 5 minus 2 3 k cap. Okay, this is called as a bar plus b bar value by adding this one. If you want to find the magnitude of this value, magnitude means modulus of a bar plus b bar. We can do this like this, square root of 6. I square means 1. Because of 1 into 1, always 1. 6 square plus anything is not there, 1 square plus 3 square. What is the value? 36 plus 1 plus 9. What is the value? Square root of 46. That is the magnitude of these equations. Magnitude of this equation. That's why we can do the sums like this. Okay, by adding the three dimensions way, we need to add the three components. That is the three dimensions: I cap, j cap, and k cap. Okay. Okay, this is the resolution of the vector. Okay, one more thing is there. In a different ways we can find out. But how can we say? See, for example, simply resolution two dimensions way. Simply I will explain here. For example, in this way. For example, if you want to take the theta here. For example, in these cases, you can take the theta here. In these cases, you can theta here. You can theta here. Okay, you can theta here. How can you write the components? See, for example, every component is there. For example, force and displacement or A, B, C, something you can write. Okay, the first quadrant we want to find out. Already first quadrant we can find out. What is the component? Horizontal component means F cos theta. Vertical component means F sin theta. Means how can you write? See, from these equations, the resolution of the vector F is equal to, for example, x-axis fx, y-axis fx cos theta plus fy sin theta. Fy sin theta. That is the first quadrant has completed. Next one. This one. This is the f sin theta. This one. This angle. Okay, what is the value? This is the adjacent side. That is the ay cos theta. This one ay sin theta. But you can remember this is the negative axis. That's why we need to write the a is equal to ay sin theta Okay, x-axis means which component is there, which unit vector is there, I cap. Y-axis means j cap. This one y-axis means this is the x-axis, na? Okay, y component. What is the y component? This is the x component. The x component what we got here, ax something. But ay is equal to ay cos theta minus, because of it is a negative axis, that is called as ax sin theta. This is the y-axis, that is called as j cap, x-axis I cap. That's why we can write easy. Okay, from this diagram, third one, this is the resultant. Yes, this is the adjacent side, this is the opposite side. We want to write here b is equal to bx cos theta I cap by sin theta j cap. Yes, but here only negative axis, that is the bx cos theta I cap plus by sin theta. It's a negative also, negative y axis, that is the y. We can write here in the j cap. That is the third quadrant equations. Third quadrant we can resolve this one. And fourth quadrant, this is the theta. This is the adjacent side. This is the opposite side. Adjacent side means what we got here, c is equal to, you're only getting the cx cos theta minus negative y axis. You're only cy sin theta on x axis. Yes, we want to write here cy sin theta I cap minus cx cos theta j cap. Okay, here we want to write the cx or cy, whatever it may be. Okay, x axis, that's why we need to write the y cap. Okay, this is the four quadrant we can now discussing the resolution of the vector. It is easy to understand, simple you can remember. If the angle between this one given, always the theta is adjacent component getting the cos component, or the other component is called as sine component. Simply we can say. Okay, this is called as a resolution of the vector 2 dimensions and 3 dimensions. The next video will discuss the resultant of the vector. That's formula is very important. Okay, by using a triangle of vector. Okay, we are discussing the next video. If you like the video, you can subscribe and share it. Thank you.